Okay, in this video, I'm going to show you guys the best possible way to passively keep horse water from freezing in this cold weather. It's winter. We recently had a minus 10 Celsius to minus 12 Celsius set of days. We had some frozen tubs. Now, there are a lot of old wives' tales and anecdotes out there on the internet. I myself received the same suggestions from one person 2 years in a row now, and I wanted to show why that doesn't work and what does work so that you guys can do it yourselves in the case that you can't use heaters or waterers. Because let's be honest, a lot of us don't have the ability to stick in underground pipes and automatic watering systems or install electricity, let alone that sometimes the electrical systems can fail, and not only will it not keep the water from freezing, but it actually can be very dangerous and lethal to some horses. Now, if you're a little bit short on time, that's okay. You can skip to this time here, which will get you to the solution. But I really encourage you to stick around and understand the science of why and how these water buckets freeze and why the method that I'm going to suggest works, because there's some very serious and cool science behind it. So by the end of this video, you are going to have an idea of exactly why and how water freezes and why the method that I suggest is going to be one of the best. Now, I should say that I absolutely take all suggestions very seriously and to the heart for everybody that worries about the horses here and how they're doing and what we can do to make them feel better. I'm also very sciencey, and I made sure to do a time lapse of the methods suggested and no method, making sure that I use this water bucket and Lena's water bucket because they are at the same height in the property, have the same amount of water, and should theoretically have the exact same set of variables that we need to measure to see if a method is effective. Now, to put it in perspective how important this is, horses drink an awful lot of water. They drink anywhere from 20 to 40 liters, which is 5 to 10 gallons per day. And as such, horses have a really high water requirement. They are 70% water, which is crazy. Kind of like humans, we have a lot of water in our body, and as such, having clean and fresh water available is very, very important so that they don't get dehydrated. So the suggestion that was made was an interesting one. The idea was to put a ball inside of the water, and based on the fact that the ball would be moving around, it would inhibit the water from freezing. Now, let's talk about why that just isn't the case. Not to say that it isn't logical, because moving water does not freeze very well, but it is just a water tub and not a little stream or river. And a ball moving around is not really quite enough movement to inhibit that freezing, especially in the very cold temperatures. So to understand why this doesn't work, we need to look no further than the laws of thermodynamics. The first law being that energy cannot be created, it can only be transferred or flows from one state to another. In this case, we're going to be thinking about the second law of thermodynamics, which states that hot energy flows to cold energy. Cold energy never flows to hot energy. So what we want to do is we want to inhibit the ability of the warmer water compared to the air to flow to the air. And that's just science. Another quick item to consider is that a larger mass transfers energy slower than a smaller mass. So for example, a cup of water will freeze much faster than a bucket of water, or a bird will actually freeze to death much, much sooner than a human, and most especially a horse, because of its mass. And that transfer of energy takes much, much longer. So mass matters. The bigger the bucket, the better. So in the case of our water buckets, which are 40-gallon tubs, it took about an hour and a half for them to form a top layer of ice. And this is at minus 10 Celsius. So just to recap, water freezes at 273.15 Kelvin, or as about 95% of the world knows it as 0 degrees Celsius. This is the freezing point of water from where it turns from a liquid to a solid. So our goal is to stop or slow down the water from getting to 0 degrees, because that's exactly when it's going to freeze no matter what. Now in this case, in the time lapse, I was able to show that in about an hour and a half, the top level of the water froze. So something to consider is the surface area that we have from the object that we want or don't want to lose heat to the object that is going to take the heat. And in this case, the surface of the water of the bucket and a little bit of the sides is what is touching the cold air. So with all of that in mind, we can now figure out through the laws of thermodynamics and understanding the surface area of each of the energy sources, that placing a ball on here, even if it does move around, will not inhibit the flow of energy from one thing to another. So the direct contact to the cold air, being at -10, is just absolutely going to freeze the water no matter what. But the question is whether or not it slows it down, which, as we can see in the time lapse, it doesn't really, because even if the water is kind of being moved around by the ball, sooner or later the ball just gets frozen in place. So now that we know the how and why water freezes and what happens based off of science, we can figure out what we can do to slow this down. So this is the solution that will inhibit the water from freezing so quickly. And we know this is because we are reducing the amount of air that is touching the surface of the water, which means that the energy from the water, the warm energy, can't flow up as fast into the cold air because there's not nearly as much of that cold air touching the water. Also, the box itself somewhat insulates the water bucket because the warm energy that's inside of there stays inside of there. You can also do more insulation in the box and around the tub, but mostly it is the amount of cold air, the surface area of the air and the surface area of the water that matters as to whether or not this is going to freeze at a particular speed. So this particular cover is very simple. It's just some 1x6s on the side, 2x8s for the legs, and then a piece of heavy plywood, 3/4 inch plywood on top, cut a hole in it, and that's it. Horses quickly figure out that this is the place to drink from. They find their water here, and they're happier because it's not frozen nearly as fast as it would be if you did nothing. Okay, so this is the difference between overnight at about -1 Celsius. That's the uncovered tub. And this is the covered tub. I've taken the cover off, and you can see that there's far, far less ice with the one that was covered. So to ensure that your horse is getting enough water, make sure to provide them with a clean and accessible water bucket with clean water in it. And if you notice that your horse is drinking more or less than usual, it might be kind of important to consult a veterinarian. But for the most part, horses are very good at managing their water as long as it's available and it's clean. So I hope you've enjoyed this video. If you have any thoughts or questions, let me know in the comments below, and I'll see you guys in the next one.